In this video, I'm going to show you how to find the molecular formula in two different examples. In the first example, I'm asked to find the molecular formula of a compound, and I'm given the empirical formula here, which is CH2, as well as I'm given the molar mass of the molecular formula, which is 84.18 grams per mole. So I know that my empirical formula is CH2. I know that the molecular formula of this compound is made up of carbon and hydrogen, but what I don't know is the subscripts of the carbon and the subscripts of the hydrogen. So let me just write down that I know the molar mass of the molecular formula, which is 84.18 grams per mole. All I would need to do in order to find the molecular formula of this compound is to take a look at the molar mass of the empirical formula. How would I do that? I just have to account for the molar mass of each of the elements and how many of those elements there are. So just like we've learned previously, carbon has a molar mass of 12.01. There's only one of those carbons, plus there's two hydrogens, and hydrogen has a molar mass of 1.01. So if I figure out the molar mass of this empirical formula, it would be 14.03 grams per mole. And in order for me to find the molecular formula of this compound, all I would have to do is compare the molar mass of the molecular formula of this compound to the molar mass of the empirical formula of the compound. So I'm going to compare these two values. The way that I would compare is to divide them. So I'm going to divide 84.18 grams per mole divided by 14.03 grams per mole. And if I put this into a calculator and divide these two numbers, I get the value 6. So knowing the ratio between the molar mass of the molecular formula of the compound to the molar mass of the empirical formula, I can use that ratio to figure out the molecular formula. So the empirical formula that I have is CH2, and I have to take each of the subscripts of the empirical formula and multiply it by the value that I just found. So I know that carbon has a subscript of 1, and I have to multiply that by 6. So 1 times 6 will give me 6. Hydrogen has a subscript of 2. 2 times 6 is 12. So C6H12. This is the molecular formula of this compound. Now, if you wanted to check to see if this is correct, all you would have to do is find the molar mass of this compound, just make sure it's exactly the one that you're given in the question, and you know that your answer is correct. Now, let's take a look at another example. In this one, you are, similar to the first one, you are given the molar mass of the molecular formula. So I know that it is 176.124 grams per mole. I know that this compound is made up of carbon, hydrogen, and oxygen, but I don't know the subscripts for this compound. Now, unlike the first one, I'm not given the empirical formula. I have to find the empirical formula given the information here. And because we've already done or learned about empirical formulas, this is easy for us. What we have to do anytime we see the percentage breakdown of the elements of a compound is to make the assumption that that compound, it weighs 100 grams. And if I make that assumption, I can then use that information to find the empirical formula. So I know that because this compound weighs 100 grams, I know that it is 40.91 grams of carbon, 4.58 grams of hydrogen, and 54.51 grams of oxygen. Now that I have the masses of each of these elements, I can find the moles, compare them to each other to find the ratio, which gives me the empirical formula. So I'm going to go through that whole process with you. So given the mass of carbon, which is 40.91 grams, I can use the molar mass of carbon to figure out the moles of carbon. So the molar mass of carbon is 12.01. If I do this process, I get 3.40632.806 moles of carbon in this compound. Start off with 4.58 grams of hydrogen. I know that the molar mass of hydrogen is 1.01 grams. If I do this, I know that there are 4.53465 moles of hydrogen, and then I've got 54.51 grams of oxygen times this relationship, which is 16 grams for every 1 mole. My units cancel out, and I get 3.406875 moles. Now, just like we did for in the video where we found the empirical formulas, you have to see whichever one is the lowest value and divide all of the numbers by that value. And the lowest number is this, so 3.40632.806. So I'm going to divide all of the other ones by that number. Because these are the same number, when I divide these two, I get the number 1. If I divide 4.5, or this number, by the lowest of all three, I get 1.3, with the 3 repeated over and over again. And then if I do this, I'll get a number that's close enough to 1. Now what I have to do. So these technically give me the ratio between carbon, hydrogen, and oxygen. I cannot express this as the formula quite yet, because as we learned in our previous video, if you've got a decimal plate, a number that's a decimal of 0.3333, I have to convert that into a whole number. And the only way that I can do that is to multiply it by 3. If I multiply this number by 3, I get the value 4. If I'm multiplying this subscript by 3, I'm going to have to multiply the other two by 3 as well. So given this, what I've just figured out is the empirical formula of this compound, which is C3H4O3. But remember that the question is asking me for the molecular formula. How would I find that? So let me just go back to give me a little bit more space. So the empirical formula C3H4O3. I know that the molar mass of the molecular formula is 176.124 grams per mole. I have to now find the molar mass of the empirical formula. Just like we did previously, I have to account for the molar mass of each of those elements times the number of each of those elements. So I know that there's 3 carbons, 4 hydrogens, as well as 3 oxygens. If I solve for this, I'm going to get the value 88.07 grams per mole. In order to compare the ratio between the molecular formula and the empirical formula, I'm going to divide these two molar masses together. So if I do 176.124 grams per mole divided by 88.07 grams per mole, I'm going to get a value close enough to 2. So the ratio between these two compounds is 2. So just like we did for our previous question, I have to take each of the subscripts that I have in the empirical formula and multiply it by the number that I just found. And the number that I just found is 2. So instead of it, so I take the subscript of my empirical formula for the carbon, which is 3, multiplied by 2. So my molecular formula is going to have 6 carbons. It's going to have 8 hydrogens as well as 6 oxygens. So this is my molecular formula. So there you go. That is how you find the molecular formula for those compounds.